Hello viewers, welcome back to the course on scientific computing using MATLAB. So in the previous lectures we have discussed about the numerical integration with trapezoidal rule, Simpson 1/3 rule, Simpson 3/8 rule, and then we have also discussed the method of undetermined coefficient. So today we will make the MATLAB octave codes for that one. So let's go to the octave. So this is the cursor for the octave. Now we can start a script file. So this is the script file. So today we will make the code for trapezoidal rule. So I'll write the function. So let's make the function. So that function give me the value area, that is it will be returning. So I call it trapezoidal. So I just write the short form trapeze, and then I will pass the value of the function, then the limits, lower limit, upper limit, and the number of subintervals. So that I am going to pass from here. So here I can write that input are f, the function, that is my f, then lower limit, that is a, and upper limit, that is p. So this one I am going to input, and the output will be, so that output will be given by the area, that is a, and this is also, here we have to n is equal to the number of subintervals. So this one we are going to define. Now I will find out the h. So what is the h? So h I will find out, that is b minus a. So that is coming from the input divided by capital N. So this one I am going to define. Then I define my area capital A, that is equal to 0. I start with this value is equal to 0. Then I will define the loop, for loop. So for I just define I is equal to from 1 to n minus 1. So in this case I am defining the nodal values I will define. So x is equal to, first is x naught, so that is a, plus the h is multiplied by I h. So that is my nodal value, because in this case if I put I is equal to 1, it will be a plus h, I is equal to 2, it is a plus 2h, because this is uniform nodal values. And then I will define capital A, this is the area, this is equal to area plus f evaluate, the value of the function f at this x. So this will be, so from here I will get the value of x, and this is the value of the a I am getting, because it is added. I started with the a 0, so initially it will be a plus, so this will be 0 plus value of the function at x, that will be added, then the next will be added, so on. So for the for loop it will keep adding these values for the value of x, and that is the value of a. So this is the and after that I just pass a is equal to, because here I am using that composite rule. So I know that this is equal to h multiply by f, the value of the function at the initial point, plus f evaluate the function at the last point, divided by, so this is, we know that we have to take the average of this value plus, and then I can define the, because it is h by 2. So, h by 2 we are defining here plus h by 2. So, this is h by 2 multiplied by the value of a, the 2 times of this one. So, that will cancel out and this will be equal to a star. So, this is the value we are going to get. So, now from here I define the function. This is the input values we are introducing here, and that is the function here. So, I can save this function, save file. So, let us save it on the desktop. So, I just save it at the desktop. Yeah. So, here I am saving. So, this will be saved as the name, and the name is trapeze.m. So, this will be saved. So, that is the TRAPEZ, trapeze door. So, this is the function I have saved there. Now, if I open again, so let me cancel this one, and then I know that this one we cannot run because this is a function. So, I have to give the input value here. So, for the input value, what I do is that I define the, suppose I define another main, I should write the main script for this one. So, in this case I just write CLC and clear all, and at the end I will define that this one I am defining for numerical integration. So, this one I am doing for numerical integration. Then now first I have to define the f. What is my f? So, f I will define as a, because I have to pass this one. So, this is just the handler I am giving, the function of x. So, let us take the function. This is I am defining x raised to power 2 plus x plus 1, and let us multiply it by cos x. So, this is the function I am defining. Let us say take a is equal to 0 and b is equal to, I am defining pi by 2. I define n is equal to, because in this case no problem, I can define n is equal to maybe 50, trapezoid rule. Then I just call the function. So, I am calculating the area. So, this is I am defining trapeze, because I am defining the trapeze, passing f, a, b and capital N. So, this I am passing. So, whatever the value it is coming, I will just write f print f. So, this is the value I am writing f print f. The value of the integration, is, so this is just defining. So, it is equal to, I am defining just 5 point maybe 2 floating point, then new line this, and that is the area. So, this is the printf I am defining. So, I am saving it because we have to save it. So, let us save it where we want to save. So, save file, and again I have to go to the previous file, moocs, then here. So, I will call it main, that is it, and let us save this one. Now, I just run this one. So, let us run this one. Change directory, yes, and after getting this value, so this is the error, it is coming area. So, we have defined the area wrong in the main file. So, let us correct it. AREA area, the printf here. Yeah. So, that is the area I am defining. Now, we can just save and run. So, let us see. So, value of the integration is coming is 2.04. So, that is the value it is coming with the trapezoidal rule. Maybe I can change this to n is equal to, instead of 50, I can take n is equal to maybe 80. The number of points I will increase. So, let us see what will happen in that case. So, yeah, so it is again the 2.04. So, it means that this is the exact value of the function, approximately exact value of the function for this integration 2.04. Maybe I can change this one, and I can change the function here. So, this function here, maybe I can just define the next function. Maybe I can write f is equal to exponential function, because that I know that it is very difficult otherwise to find out the solution. So, let us take this exponential function. So, in this exponential function I am taking b is equal to a is equal to 0, that is okay, but instead of taking here, I define my a is equal to, maybe a is equal to 0, and b I just defined 1. So, let us see what will happen, and the number of mesh point I am taking 80, it does not, so no problem in this case. So, let us see what will happen. So, the value is coming 0.75. So, this is basically the integration from 0 to 1 e raised to power minus x square, the Gaussian function, and the value is coming 0.75. So, in this way we can define the different type of functions, and that is the trapezoidal rule. So, maybe we can define the another function. So, let us define another function. So, now we will do the another function for Simpson maybe. So, let us take another one. So, I define the function, the area I just define same as Simpson. So, I am defining Simpson 1, and again I am passing f, a, b and n. So, that we have to do pass this value. Then I know that input is again, because this you have to write as a comment that if you open this code after a long time, then you should be able to see that what is written in this code and what is the use of this code. So, in this case input I am just writing again, the input is f, the function f a is lower limit, b is equal to upper limit, and then the n is the number of mesh points, number of, maybe I can write sub intervals. So, this is a number of sub intervals. Now, in this case I know that if I apply the Simpson 1/3 rule, then I should write that for Simpson 1/3 rule, n should be multiple of 2. So, that should be there. Only then we are able to divide the given domain or given domain in the required number of mesh points. So, in this case I know that the n should be equal to 2k. So, it should be even basically. So, in this case what I am doing, I just find the h. So, h I am taking b minus a, that is divided by 2 star n. So, I just write it 2 star n. So, whatever the n we are passing, I just multiply by 2 times, that is it. So, maybe then there is no problem. Suppose I just apply n is equal to 5, then I will get 10. So, 10 is a even number, no problem. So, I just do like this one, then I define the sum. So, I define the sum S1 is equal to 0, the initial sum, S2 is equal to 0, because in this case we need to find the two type of sum. One sum is multiplied by 4. If you remember the Simpson 1/3 rule, we have to apply this, we have to find the two sums. One sum is multiplied by 4, another sum is multiplied by 2. So, now we define the for loop for I is equal to 1 to n. So, this one I have to define. Now, x is equal to the initial a plus h time 2 star I minus 1. So, this one I am defining. So, when I is equal to 1, so this is I equal to 1, it will be a plus h. When I is equal to 2, it will be a plus 3h. So, 2 into 2 is 4 minus 1, 3. So, a plus 3h. Then I is equal to 3, it will be a plus 5h. So, basically you are getting the value at the odd values, a plus h, a plus 3h, a plus 5h, like this one. And then I define my sum S1 is equal to S1 plus the value of the function at this x. So, that we are calculating. So, this is the sum giving the values at the odd number of nodal values. So, basically it is a plus h means x1, a plus 3h is x5, like this one. Now, I define the another loop I, that is j from 1 to n minus 1. So, this one I am defining, then x is equal to a plus h, and that is multiplied by 2 times j, because here I am defining when j is equal to 1, it will be a plus 2h, then j is equal to 2, it will be a plus 4h. So, it is the even values of the nodal value. So, this I am defining a plus 2hj and then s2 is equal to s2 plus the value of the function f at this x. So, this is the value we are defining, and that is the end of this for loop. And then I can pass my area. So, A will be, now you can know that this is 3 by h 1 by 3 rule. So, I will define h by 3, that is multiplied by the initial f evaluate the function f at A plus f evaluate the function f at B. So, this is the values I am defining, this one. So, I can define plus 4 times S1 plus 2 times S2. So, this is the value. So, it is a 4 times S1 because we are getting the values at the odd values, and 2 times the S2 where we have a overlapping nodes. So, that is the even values. So, we will get the value at x2, then x4, then x6, like this one. So, this is the way we are defining this function. So, this is a Simpson 1. Now, I just save it, and this will be Simpson 1. That is it. So, now I will just use the same main file. Let us see what will happen. So, the same file I am using, just I will change the name here. So, in this case, this is my area. Now, I define this value and define the area, that is equal to Simpson 1 f at A at B, and this is the number of points, and so that is it. The only thing I have changed is the calling function, that is it. So, let us see what will happen. It is solving or giving me some error. Yeah, so it is giving some error that some extra bracket is there. Okay, so let us see. So, let us see to Simpson 1. So, in this case I am getting function of value of the function at A plus the value of the function at B. This is okay, plus 4 times S1 plus 2 times S2. Oh, this is the extra. So, now it is okay. So, I will just save it. Now, let us see. And let us see that whether we are getting the result. Yeah, so we are getting the same result, 0.75. So, now we can even, let us see what will happen when whether we are getting the same result for the previous case. So, let us take this value here, I take this f and comment this one, and now I am also changing value of A and commenting this one. So, let us see what will happen. So, in this case value should be 2 point something. Yeah, so it is 2.04. So, from here also we are able to solve this integral, with both the methods, Simpson 1/3 rule or Simpson or trapezoidal rule. So, in this case, and I also know the Simpson 1/3 rule is same as the Simpson 3/8. So, this will also work for that. Then, so maybe this are used a lot whenever we are finding the length of the curve. So, in the case of the length of the curve also we need to find the integration, and this is will be very useful whenever we are dealing with finding the length of the curve or the surface area. So, the numerical integration is essential in that case. So, and everything we are doing for one dimensional. So, maybe we can take another function. Instead of f, I just take another function. F is equal to, maybe I just take the simple function x raised to power x raised to power cube. So, this is the function I am defining. Then I define the function. So, I just define it f1, and then I define f is equal to the derivative of this one. So, it will be again 3 multiplied by x cube. I am taking the derivative, and then this is, I just take note the f, I just write df, the derivative of f1. Yeah. So, this is I am defining. Now, what I am going to do, I am going to find out the length of the curve. So, now I define f is equal to, because I know that the value of the function. So, f will be the square root of the function 1 plus. So, I know that the formula is 1 plus f dash square under the root. So, square root 1 plus. So, this f dash is the derivative of the function. So, I will write df1. So, this is basically I just defined, in this case it is 3 star x power cube. So, this is the derivative square this one. So, that is the function 1 plus f dash square under the root, and I want to find its length. Maybe I just change it from from 0 to 1, okay, and I am applying with the Simpson 1 rule. So, this it will give me the length of the curve from 0 to 1 for the function x cube. So, let us see what will happen. So, it will give me the value of the, so that is 1.40. So, that is the length of the curve from 0 to 1 for the function x cube. So, here I can write the value of the integration. So, just instead of this I just control C, and then I control V, and then I from here I write the length of the curve. Length of the curve is this one. So, this in this case it gives me the length of the curve, that is it. And if I run this one, I will get, so the length of the curve is 1.40. I can do the same thing with trapezoidal. Let us see what will happen. So, I should get the same value. So, it is 1.40. So, it is giving me the length of the curve for both the methods, trapezoidal or Simpson. So, I think now I should stop here. So, today we have discussed that how we can make the functions code for trapezoidal and Simpson, and we have able to verify that it is giving the results for both the methods. So, by this way we can make the code for other numerical methods also. So, this is just a preliminary that how we can use the MATLAB code for numerical integration. So, this is all about the method based on numerical integration. So, that is all about the numerical integration. So, thanks for watching and thanks very much.